So now we will have the discussion on refraction through prism. Now, if you look over here, prism is something of this shape. This is my prism. Now let's, in your book, practically, if you look in your practical course, you will see that prism is something like this, but in your book it's given something like this. So I urge the students not to get confused, because if you look at the 3D diagram of prism, it will be somewhere over here. So when they give you a diagram that a ray of light is coming and striking at this point, this is the point of incidence. Say suppose I draw a normal at this point. It's a normal. So the light after reflection, because say suppose it is traveling from medium N1 to medium N2 and back again to medium N1. So it will undergo a refraction and it will travel straight. Now if you take this as a normal, now this again will undergo further refraction and it will come somewhere over here, somewhere over here. So now if you try to imagine the ray of light, this light was traveling here and it was supposed to be going this side. But instead it went this side. So you can see it is making an angle E, then it is again making an angle over here, it's making an angle, say suppose R. So this is R1 and this is R2. So there are multiple refractions that is taking place. So this is how we can physically understand prism. Now let's see how are these angles related to each other. Now let's name this is angle I. This is angle of incidence. Angle I, angle of incidence. Now this is the final angle. This is a final angle. Angle E is the final angle. And we name this as angle of emergence. Angle of emergence. Emergence. Now if we talk about this angle, if you magnify this structure, this is where I've magnified this structure. Now this is if this ray is coming over here and the angle of incidence is I. So because of this we have an angle of refraction. What is the angle of refraction? If we want the angle of refraction, we would be wanting this. Say this is the normal, this is the normal. So the angle of refraction is somewhat, if this ray goes over here after refraction, so this is R, this is R1. Now because of this R1, this part strikes the wall over here, and after it strikes the wall over here, it again undergoes refraction and it comes out. So this particular angle, if I draw a normal at this particular point, so this particular angle is the angle of emergence. This is emergence. E-M-E-R-G-N-C, emergence. And this is making another angle. Now please keep in mind, these are not vertically opposite angles. These are not vertically opposite angles. Now this is being deviated somewhat. This is being deviated somewhat. So this angle and this angle is not equal. So this angle, let this be R2. So we have named this prism as A, B and C. This is I. See, suppose this is ray P. This point be Q. So this point of intersection be N. And let this point be R. And the line the ray that is coming on BS. So now if you look at the quadrilateral AQNR, AQNR, this is a quadrilateral. This point, this point, this point, and this point. It's a four-sided quadrilateral. Quadrilateral AQNR. Now we will be talking about this. Now, if you look closely, angle A, this is angle A, plus angle QNR is equal to 180 degree. Now, why is this 180 degree? Because this is a cyclic quadrilateral. This is a cyclic quadrilateral. Now, if you ask me why is this a cyclic quadrilateral, if you look over here, this particular line is making 90 degree. This particular line, angle AQN, because we are drawing a normal to this line AB normal, so angle AQN is 90 degree. Similarly, the opposite side, angle ARN, we are drawing a normal, this is also 90 degree. So if this and this is 90 degree, then 180, so the opposite angle, this and this, should also be 180 degrees. So angle A plus QNR is equal to 180 degree. Now if you look from triangle QNR, so from triangle QNR, what we have is R1 plus R2, R1 plus R2 plus QNR. Triangle QNR is also equal to 180 degree. Now if you compare this to equation, let this be equation and let this be equation 2. So now after comparison, what we have is R1 plus R2 is equal to angle A. Angle A plus QNR. So what is this? QNR plus angle A is equal to 180. QNR plus this two angle is also equal to 180. So QNR and QNR is equal. So angle A is equal to angle R1 plus R2. Or if you want this result, straight away subtract equation 1 from equation 2. You will have A minus angle R1 minus angle R2 is equal to 0 degree. If you take 1 minus 2, this implies A is equal to angle R1 plus angle R2. Now, if you look at the total deviation, say suppose what is the total deviation that we have? If someone asks us, say if you are going inside with this angle and you are coming out with the angle of emergence E, so what should be your total deviation? How much did the ray deviate? And that deviation is denoted by this delta. So deviation is equal to incident minus the refracted angle I plus emergence minus R2. So how much does it deviate? So this much deviation. So this angle minus this angle. So there is a slight deviation over here. That is deviation. Say suppose D1 on your first surface. On your second surface also there is a deviation. That is R2. This is the emergence, and how much does it deviate? That is this angle emergence E minus R2. So if you add this two, you will have your total deviation, and your total deviation is given in this way. This is your total deviation. So now deviation is equal to angle of incidence plus angle of emergence minus A. Now what is A? This is the angle. So how much angle is the prism making from its top, from its tip, and this is responsible for your deviation. The smaller it is, now please keep in mind, the smaller this angle A is, the more deviation there will be. The bigger the angles, that is bigger the tip of the pyramid, the lesser the deviation will be, and this is how we can understand. So this is your formula for your deviation.